Welcome back. We're going to be talking about inscribed angles. Oh yes, it's going to be a party. Join in. First, let's start with what an inscribed angle is. An inscribed angle is an angle with its vertex on the circle, and we've talked about this, and the two sides that are chords. All right, so if we look down here, here's the vertex on the circle, one chord BC, segment BC, and the other chord is segment BA or AB. And that chord intercepts an arc, right? This arc AC. And that intercept arc lies between the endpoints of the inscribed angle. And the degree of the inscribed angle is equal to 1/2, right? Half the measure of the intercepted arc. So in essence, what we're saying is, if this was 80 degrees, then this would be 40 degrees. The measure of the inscribed angle is half of the arc that it intercepts. Next, as we move across, or I should say down, talks about if an inscribed angle intercepts a diameter. So here's the diameter that it's intercepting, and we're talking about this angle right here. So if that angle intercepts a diameter, then it's a right angle. And therefore, the measure of angle BA, right, with the vertex at A, is equal to 90 degrees. And lastly, and this is super important, so just put a little asterisk here, if two inscribed angles intercept the same arc, right? So they're intercepting the same arc. So we're going to be talking about this arc AD. So you have angle ABD. Where's that? That's from A going towards B over to D. Notice that intercepts this arc right here. And then we have this arc over here, or I'm sorry, this inscribed angle that's also intercepting the same arc. And that is angle ACD. Those measures are going to be the same. So let's take this newfound information and let's see if we can hammer out a few answers to some questions. First, we have the degree of the inscribed angle is equal to half of the intercepted arc. That's the notes we just took, and here's our picture. This angle here at B, at vertex B, angle ABC, is 1/2 the measure of arc AC. So here's the arc, and here's our inscribed angle. And what do we know? We know that the measure of angle WXY is equal to 1/2 of the measure of arc WY. So when we put this into numbers, I know that this is 62 degrees. So over here has to be equal to 1/2 of that. 1/2 of that is 31 degrees. So this must be in here 31 degrees. Again, as we move along, we see a vertex of an inscribed angle. The vertex is on the circle. Chords are the sides. And that intercepted arc is this big piece here. So remember, if I think about this, the angle is equal to 1/2 of the arc. Or we could also say that twice times the angle is equal to the arc, depending on which way I'm moving. I have that the angle, right? The angle is 113 degrees. So 2 times 113 will be the arc. So that puts us at 226. So the measure of arc D, starting at D, heading to G, ending at F, is 226 degrees. So now that we've been taken around with that, we'd look at this inscribed angle here. So here's our inscribed angle with a vertex at Q and sides that are chords. And it intercepts this diameter, which means that this right here is 90 degrees. And doesn't that make sense? Because this diameter means that this area is a semicircle, which means that this arc is 180 degrees, which means that this angle, that inscribed angle that intercepts that arc, is 90 degrees. So angle PQR is equal to 90 degrees. And that was just basically by definition, but it makes sense. Now we come across an example that's a little bit more busy and looks like we're probably going to use that concept of intercepting the same common arc. And you know, I'm from the camp of let's fill out the picture as much as we can first. But let's see what we got here. The measure of angle RST, that's from R down to S over to T. That would require that I know this arc. And then also over here, we have angle RUT. So from R down to U up to T. So what do I know? I know that these angles are congruent because they intercept the same arc. If only I knew what this arc was in terms of degrees. But I do know that from R all the way around the circle is 360 degrees. And I know that this part's 75, this part's 139, this part's 64. So if I just keep subtracting those from 360, I'll get the measure of arc RT. So let's figure that out numerically. I get 82 degrees when I subtract this group from 360. So that gives us the measure of arc RT, which makes this 82 degrees, which makes this angle and this angle 1/2 of 82, which leaves us with 41. So 41 degrees is the measure of both of those angles. Piece of cake. You just got to color code it. Get some colored pencils or some highlighters to help you with this. Okay, colored pencils are suggested. Now we move into the algebra portion of the game. You know this is coming. So again, here's my inscribed angle, and out here is my arc. So I know that twice the measure of the angle gives me the measure of the arc. Or the angle is equal to 1/2 of the arc. Now, I would prefer to double the angle and set it equal to the arc rather than taking 1/2 of the arc to avoid decimals. But let's approach it both ways for just one problem. So first we'll take 2 times 67. That should be equal to 4x plus 58. The other version would be to say that 67 degrees is equal to 1/2 times 4x plus 58. So either I double the small one or I take half of the large one. Either way. Now, over on the halvesy version, I'm going to get 67 equals half of 4x is 2x, and half of 58 is going to be 29. So not so bad. I don't think I'd like this if there were odd numbers inside to take half of, because then I break decimals into the situation. And I'm going to get 38 is equal to 2x. That cancels out. Divide by 2, and x is going to be equal to 19. Let's see how this works over on the other side. If we take 2 67s, I'm going to get 134 is equal to 4x plus 58. Subtract 58 from both sides. And I get 76 equals 4x. That cancels out. Divide both sides by 4. And I get an x of, lo and behold, 19. So whatever way is easier for you, solve for x. X equals 19. The key to this whole situation is to write true and solvable statements. So let's see, we're going to solve for x, and what I see is 7x plus 6. So I'm just going to put 7x plus 6 here equals. And so what do I know? I know that that's the angle, so 2 7x plus 6's is going to equal what? Here's the angle. I'm going to trace that, right, with my colored pencil, and I'm going to find the intercepted arc. This is the intercepted arc, and I need to know what that is in degrees. I don't know that in terms of degrees, but I do know that this is 78 degrees, and I know that this is 114. So this intercepted arc of the 114 legs is going to be twice 114, which again, from a few moments ago was 228 degrees, very similar. And now I'm going to take 360, I'm going to subtract 228, I'm going to subtract 78, and that'll give me what's left. That'll give me that blue arc, arc XY. So I'm looking for the measure of arc XY. And that's going to equal 54 degrees. So this is 54 degrees right here. And that's what goes right there, 54 degrees. So now I distribute the 2. I'm going to get 14x plus 12 is equal to 54. Subtract 12 from both sides. I'm going to get 14x equals 42. Divide by 14 and divide by 14. And I have my answer for x. That gives us a value of 3. And we are moving along nicely. Again, true and solvable statements. Start with what you know. I know that this angle right here is half the size of its intercepted arc. So this arc, QS, the measure of arc QS is equal to twice the measure of angle QRS. So essentially that arc is equal to 2 times 67, which is going to be 134 degrees. So this is 134 degrees. Now again, all the way around is 360, and what I really like to know is what this arc is, because I know 5x plus 21 is what that arc measure is in terms of algebraic expression. So I come over here, 360 minus 134 minus 120 will give me the value that 5x plus 21 is equal to. Well, 360 minus 134 minus 120 is 106. So I place there the 106 right there, and I'm going to solve for x. You finish. Okay, now we come on to the measure of angle STU, and where's that? That's right here. That's this angle right here. It doesn't quite pass through the vertex, and that's worth 5x minus 16 degrees. So this is the value of this angle right here. And the measure of arc SU is 12x minus 50 degrees. This is the arc right here. That is the measure of that arc. And so what do I know? I know that 2 of the green version, right, 2 of the 5x minus 16 is equal to 1 arc. Or I could always say, right, or I could say 5x minus 16 is equal to 1/2 of 12x minus 50. Both of these statements will get me to the right place. So I'm going to solve for x. All right, so you can distribute and deal with this how you'd like, or you can distribute and deal with this how you'd like and get a value for x. And then once you get the value of x, the final answer is the measure of angle STU. So I'm going to take my value of x, right, after I get it, and I'm going to substitute it into there, and I'm going to get a final answer. The measure of angle STU is equal to something. So first, I'm going to get the value of x. Second, I'm going to substitute it in and get the measure of angle STU. And again, you finish this one. All right, so now we move on to a picture that's slightly busier, and let's see if we can make sense of it. First, we're looking at the measure of angle ABD. So starts at A, goes towards B, ends at D. Looks like that intercepts arc DA. Then I notice that I have an angle ACD. Starts at A, goes towards C, ends at D. Notice colored pencil's a must. And what do I know about these angles? These angles are congruent, and they both intercept the same arc. Now, what I notice is that they happen to be asking me for the measure of arc AD. So that would require that I know either this angle or this angle. I could figure out that angle if I knew the value of x. But what do I know about these two angles? That they're congruent. So 6x plus 26 is equal to 13x minus 9. As I subtract x from both sides, or I should say 6x from both sides, and simultaneously I'm going to add 9 to both sides, so I kind of do this in one fell swoop. That cancels out. 26 plus 9 is going to be 35. and 13x minus 6 is going to be 7x. Just so happens that 35 divided by 7 is a value of 5. So I take that value of 5 and I substitute it in here. Now, 13 times 5 happens to be 65 minus 9. And that gives me a value of 56 degrees. So what I know is that this angle here is 56 degrees, and also this angle here is 56 degrees. And what do I know about this arc out here? It's twice the measure of the inscribed angle, which is going to get us 112 degrees. So the measure of arc AD is equal to 112 degrees. Again, to recap, I know that my two inscribed angles that intercept this common arc are congruent, so I set them equal to each other. I solve for x. I substitute x into the value of one of them to get the value of technically both of them. And I know that the intercepted arc is twice the measure of that angle. So after I got the measure of the angle, I multiplied it by 2, and I got 112, which is the measure of my arc. The last little piece of this is kind of neat. If a quadrilateral is inscribed, right, that means written inside. Scribe means to write in, inscribed in a circle. So I have this quadrilateral over here, and if this quadrilateral is inscribed in a circle, which means that its four corners are on the circle and the rest of the quadrilateral is in the circle, then its opposite angles are supplementary. Now, that's a word we haven't used in a while, but it is associated with the value of 180 degrees. Right? So two angles whose sum is 180 or are 180, opposite angles are supplementary. Then that means that the measure of angle A here plus the measure of angle C is equal to 180 degrees. And also, we have that the measure of angle D and B, right, they're opposite angles. The measure of angle D and the measure of angle B, if I add those up, I get 180 degrees. Beautiful. So this is just over and above what I already know about these inscribed angles. Let's put it to action. Okay, there's a lot of stuff going on here, and let's see, we need angle P. So we come over here, and I know that this is angle P. I know that angle R plus angle P adds up to be 180 degrees. I don't know anything about angle R, so I can't subtract from 180. Angle R is the other thing they want me to know. Well, not much going on there. So I keep moving around, and I see angle S. So really, I need to know all three angles of this quadrilateral that I don't have. Now I know that angle Q and angle S are opposite angles, so I know that 93 plus the measure of angle S equals 180. So when I subtract 93 from 180, I'll have the measure of angle S. We'll start there. So that yields me 87 degrees. Now I have to start getting savvy. So I'm looking at angle R, and I see that angle R is an inscribed angle, and the arc that it intercepts is this large arc from S all the way, I'll choose a different color, from S all the way to Q. And I know that 90 plus 126 add up to be that arc. So 90 plus 126 is going to yield me 216 degrees. And I know that half of that arc is what this angle is equal to. So I take 216 and I divide that in half. And I'm going to get 108. So angle R is 108 degrees. So I put that there. Now I know that angle P and angle R are supplementary. So 180 minus 108 is going to yield me 72 degrees, and that's going to be my last angle here, 72 degrees. The last little way I could check this is I know that it's a quadrilateral, and I know that the sum of the interior angles should add up to be 360 degrees. So taking my 93 here that I was given, and then the other three, I said it was 72, 108, and 87. I add those all up. I do get it's 360 degrees, check. So I know that these are all set. Looks good to me. Again, looking at it algebraically, I see that this 62 minus 5x is referring to angle T. And then I see that angle V across the street here, its opposite angle, is 133 degrees. So what do I know about 62 minus 5x and that 133? Well, I know that the measure of angle T plus the measure of angle V is equal to 180. So this is the measure of angle T, and this is the measure of angle V. So if they add up to be 180, then this equals 180. Combine like terms. So 133 and 62 is going to be a 591 minus 5x equals 180. When I subtract 195 and subtract 195, here's the catch, right? Be careful with your arithmetic. The negative 5x comes down, and 180 minus 195 is going to be negative 15. Divide by negative 5, divide by negative 5. X is going to be equal to a positive 3. They said solve for x, so x is equal to 3, and we're done. All right, one more, just for the sake of note-taking. Quality notes. Let's get a true and solvable statement. We have angle W is right here. That's angle W. And angle Y is over here. That's right there. These guys are opposite angles, so I know that the measure of angle W plus the measure of angle Y is equal to 180. At the end of the day, they're going to want me to find what angle Y is, so I just need to find X and substitute into this. So we'll set up a little true and solvable algebra statement. The measure of angle W plus the measure of angle Y is equal to 180. So let's just substitute. W is 5x plus 1. Y is 13x minus 37. That all adds up to be 180. Let's combine like terms. Right? Gives us our 18x. Combine like terms with the 1 and the negative 37. That's minus 36 equals 180. Okay, you solve for x, then take that value of x, substitute it into here, and get yourself the measure of angle y, and report in. Now your mission is to go back and complete all of the problems on these first 3 pages that we've worked on, that were not covered or not completed in the video. Then, working solo or with a partner, complete the giant circle challenge. Okie doke, good luck. As always, thanks for listening and working with me. Appreciate it.